Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada the Engineer. Got me pinkified with me, Mr. Lady Ada. Not pinkified, but it's us two here again for Ask an Engineer, the most fun, longest living 1 hour engineering show on the internet. We're gonna have so much good stuff, lots of fun new products, another toy hacker segment.
Yeah, it's a fun show.
3D Hangouts is back. You got Iron MPI, JP's Pick of the Week, and more.
That's right.
Mr. Lady Ada, what's on the show tonight and what's the code?
Tonight's show, the code is PM Feather, 10% off the native restore, all the way up to 11:59 p.m. Eastern Time, or when I remember to turn the code off. So, use or lose it, get 10% off. And of course, it's because we have our prop maker, Featherwing. So, you can wait till the end of the show to watch and see what this is, or you can just add it to cart now and get ready. Talk about some of our live shows that we do, including Show and Tell. We just finished that up. Did LadyAda on Sunday, including a great search. We'll have a little bit of recap of that, including JP's product pick of the week this week. We'll do some factory footage. We got some 3D printing videos. We got Iron MPI. We've got a special top secret, which is a twofer because it's our My Little Hacker toy hacking, and it's also some upcoming cool new plural products, I think, that we're going to be releasing for people who like to make animatronics to music stuff and more. Have some new products. We'll answer your questions. We do that on Discord, adafruit.it/Discord, where you can join all, like, almost 40,000 of us now. There's a bunch of us there. All that and more on, you guessed it, Ask an Engineer.
Yay!
Okay, so code's PM Feather, 10% off. And you get free stuff when you add stuff to your cart, including...
We have the freebies back. $99 or more. The standard Chroma Proto half-size breadboard is still available when you order from Adafruit.com. $99 or more. We also have... Oh, skip. That should be last.
Oh, whoops. Sorry.
Yeah, it's okay.
Yeah.
$149 or more. You get a black KB2040. The K is for keyboard and B is for black. I don't know.
Yeah.
It's an RP2040 board with the same pinout as the Pro Micro, so it's a great update. But it's got STEM IQT connectivity, built-in button, RP2040, dual core 130 megahertz processor, 8 megabytes of flash, and USB Type-C. We have, go to the UPS thing.
Wow, I put these in the exact wrong order.
That's fine. $199 or more, you get free UPS ground shipping in the continental United States, and now it's time.
Yeah, because we put a new graphic up, and I just went the opposite way when I
Yeah,
it's this,
yeah,
and then it's
that's
this
that
and this.
and this. I actually did a numerical order.
Yeah.
$299 or more is the back in stock Circuit Playground Express, a sign that the world and chip shortage is healing.
Get in there.
We're getting chunks of Circuit Playground Expresses back in stock because we've got 7021 chips in the house. This is our all-in-one development board, great for using with CircuitPython or Arduino. It even has some MicroPython support now.
Yeah.
Rust and Golang. It's got LEDs, sensors, buttons, and more. We haven't done a lot of Circuit Playground projects lately because they haven't been in stock. But now that we're getting them back into the shop, I think we'll start doing some more projects again.
Yeah. All right. We do Desk of LadyAda every single Sunday. It's in two parts. LadyAda, what was part one this week?
Well, I wanted to give an update because we missed the previous Desk of LadyAda. So we skipped a week because we were out of town. So this week we did a update on the Teddy Rock spin hacking. I talked about that last week on this show, but Desk of LadyAda, I got into more depth. I showed some of like the files that modded, Android versions, running it on a Raspberry Pi, running it in an emulator, running it on a Raspberry Pi 2, Raspberry Pi 4. So many options. How we got modern linked libraries.
Yeah.
And showing a live like hacking of a story file.
So we'll show a video of that later.
Yeah. So we saw the toy hacking we're doing. So that's actually almost done because we finally had an easy way to modify the audio files in the Teddy Rock spin. So that's what I did on the first half.
Yeah, and then for Desk of LadyAda, when we look at things on digikey.com, what did you look up this week?
Okay. So this week we did a special, actually we did twofer. We did a special request. Somebody tweeted at the Adafruit Twitter account, Phil saw it, and they requested an analog output Hall effect sensor that would detect a magnetic field and give you an analog output based on the strength of the magnet, and that's exactly something that DigiKey has tons of stock of. So I found a good option with different polarity configurations, different strength configurations, low cost. I think it was like 40 cents or less from TI, and can detect both north and south magnets with 1 volt being no magnetic field at all. So a really good option.
Okay. And then every single week we do JP's product pick of the week, where we broadcast live from the product page. Here is this week's highlight.
The Neo Driver I2C NeoPixel board. This is the Le Potato from Libre Computing, and this can't drive NeoPixels on its own. I now have the Neo Driver board plugged in over I2C to the Le Potato, and then I have power coming from a 5-volt DC supply, and then I have a nice NeoPixel strip, about 60 NeoPixels, plugged into these little terminal headers here. This is using Blinka. That, and rerun it. And here you go. This is not slow. At first I thought, uh-oh, this is, with all these warnings, is this going to be disappointingly slow and we're going to be sad? But no, I'm here on a little single board computer that can't on its own do NeoPixels, and yet with our little Neo driver we are doing some very respectable NeoPixel driving. Is the Neo driver. It is an I2C Stemma QT NeoPixel board.
All right, and tomorrow is JP's workshop, and then Fridays is deep dive. Let's do some Python on hard. We have like breaking news that we're going to talk about.
Beep, 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 beep. Blinka, what's the latest?
Well, just a little bit of a reminder. This is our newsletter. Sign up for it. It is massive. We have the 8.2.0 beta 1 release. You can check out the notes. We have all the news that we put in. Special thanks to Anne, who's doing an amazing job. And Anne was on a podcast, so you can listen to an interview with Anne, the editor of the newsletter. But since this came out yesterday, Raspberry Pi posted today something that I know a lot of folks are going to ask about. So I said, hey, LadyAda, how about we just talk about some Python on hardware relating to the Raspberry Pi Pico W. So as of today, what's new with Python on this particular bit of hardware, and what can it do?
Okay, so the Pico W is the RP2040 board from the Raspberry Pi Foundation. It's like about a year old-ish. And on board is that Infineon, I guess it was Broadcom, then Cypress, now Infineon, CYW43439. And that's a combination Wi-Fi, Bluetooth, and Bluetooth low energy chip. So the thing under that tin on the Pico W. And it's the thing that, it costs $2. It's, baked into the cost. And Wi-Fi support was added, fairly quickly-ish. To the SDK and to MicroPython, so you could do Wi-Fi. And we added Wi-Fi support as well to CircuitPython. Arduino also has Wi-Fi support. And then the next side was people were like, well, it can do Bluetooth Low Energy. We want Bluetooth Low Energy support. So there is the ability now to do Bluetooth and Bluetooth Low Energy, so Bluetooth Classic and BLE. I guess you can do both at the same time, or you do them individually. Bluetooth Classic is kind of best for keyboards. And SPP. Those are like the two things people use it for the most. Bluetooth Low Energy is used for kind of everything else modern style and for interfacing with apps. In this case, they're using the Punch Through Light Blue app, which totally is a blast from the past.
Oh, yeah.
Remember Punch Through design?
Yeah.
Yeah, that was like 6-7 years
Whoa.
ago. I guess their app is still available. You can also probably use it with Bluefruit Connect.
Yeah.
Which is our app. And also,
there's an update. Since we went live, the Bluetooth support is merged upstream into the official MicroPython repo.
Yes.
Well.
I think it was in a fork, and now it was in the SDK. Like a few months ago, they released it was in the SDK. And then now it's been merged into MicroPython. So from within MicroPython, you can make, Bluetooth keyboards, wireless keyboard support. HID support isn't in there, so you'd have only Bluetooth, low energy Bluetooth Classic. But maybe for some people they just want wireless. So the next question is, Mr. LadyAda.
Well, everyone's going to ask when it's going to be added to CircuitPython. Yeah, that's what I mean.
The answer is I don't know. The answer is we have to take a look at it. We already have Bluetooth support in CircuitPython, and so what we want to do is figure out, can we make it compatible with our existing API, because that would be ideal, because again, we have existing BLE support. And I've also been kind of dancing the idea of adding Bluetooth support, classic or BLE, through the ESP32. And we're not, again, it's like we kind of want to ideally figure out a way to support everything and with the same API and without a lot of complexity. And it's not trivial, because CircuitPython has a couple of weirdnesses. Like, we like to be able to dynamically add descriptors to the BLE peripheral descriptor, like what services are available. And it's not clear whether this stack, I think it's called like Blue Kitchen, or the
Yeah.
ESP32 has
It's
it.
the BT stack library from Blue Kitchen.
And it's not open. It's commercial use only. So it's like, if we use it, sorry, it's licensed for commercial use with the RP2040, which is fine. But we would still want to have it again work with our existing API.
Yeah.
The answer is I don't know. Wi-Fi is a little easier, because Wi-Fi is kind of like, you can, you scan, you connect, you open a socket, you close a socket. There's not a lot of weird things about TCP/IP over Wi-Fi, whereas, or UDP over Wi-Fi, whereas BLE, everyone kind of has their own little idea of how to implement the API. So the answer is we don't know. We haven't really looked at it. Something we might be looking at in the next couple months, but there's no ETA. So if you need it for your project, go with MicroPython.
Yeah, well, you can just drop the EF2 on it. Now use it for that, and then when you need to do something
Swap
else,
back and forth.
I like the fact that microcontrollers are starting to turn into like little computers, where it's like, I want to run this operating system on this because this is what I want to do. Like, toss Linux on this machine because I want to do this.
Yeah.
Oh wow, I want to do something else. Toss Windows on it. Oh, I want to do something else. Toss a different operating system, or a different flavor of Linux, for instance. So I kind of like that you can bounce between these, and it's a non-destructive way to do it. You don't have to like kill your microcontroller. You can just drop a new UF2 on it. And
Yeah.
You're fine. You can have multiple ways to do something.
Yeah.
Anyways, so that's kind of neat. So that was our kind of Python on hardware news that I wanted to get out, because it just happened. Folks are going to ask us, and so I'm like,
Now you can link to this.
I can just say, here you go.
Here you go.
And that is our Python on hardware news this week. Don't forget, stay current with anything with CircuitPython. We deliver this to your mailbox every single week. Go and find it on adafruitdaily.com. We do not do anything with your email address. We decided to have a completely separate website. That way, you know for sure, if you buy something at adafruit.com, we're never going to contact you unless it has something to do with your order. And then Adafruit Daily is a completely separate site. And we don't like spam, probably more than you don't. All right, we're an open source hardware company, LadyAda, to prove it. We do a bunch of guides. We release hardware. We release files and software.
Yes,
hardware.
We have quite a few guides this
We're
week.
super sherry.
Some weeks we have like a bunch of guides, and some weeks we have many.
It's a big word this week.
We have a bunch of product guides. So Kattni did the NeoKey socket breakout for the both MX and Chalk version, the chunky on the left and the skinny on the right. Those two breakouts are very similar but not identical, so they needed a guide that covers both. Kattni wrote up the guide. And she also followed up with a encore of the TRS jack breakout. Doesn't have code in it one, but people want to get the dimensions, they want to get the schematic, and they want to get the board file. So we have a guide now for that TRS jack breakout. Very handy. I personally needed this breakout for me to do some wiring testing, because I needed something with the switches. So check that out if you want to download the files, or I don't know, get more details about the pinout. We have a 3D Hangouts project again this week. This LED Ultra Hand from Tears of the Kingdom, the new Zelda Switch game. It's a prop project using nudes, and there's no coding. There's a little bit of soldering, but it's just a battery and these LED noodles soldered together to make a cool Ultra Hand, two-piece part, one for the palm, one for the arm. Nudes are great. Normally this would have been done with EL wire, and EL wire kind of sucks to use. So I'm really glad that we found something better to use instead. And then Jepler had a project. He wanted to build an all-in-one CPM emulator that runs on the RP2040 and has DVI output. So it connects to a TV like old computers did. And it has USB keyboard input. So he used two feathers, a USB host feather to do the keyboard part, and then a DVI feather to do the emulation and DVI output part. The code's in C. I think it's an Arduino. And it uses the Pico DVI library, and he got Zork running on it. And you can run a CPM. You run CPM and then as the emulator, and then run programs off an SD card. I think he's got a SD Featherwing connected to, and you can load games on. And
Zork's kind of like a Hello World.
Yeah.
It's like, can it run Zork?
Well, it's like, can it run Doom? Well, it's like CPMs, no, they can't run Doom, but it can run Zork. So that's kind of cool. And so check that out. And then I think we had a couple updates. Let me scroll down. Looks like Liz updated the Pico W HTTP server, probably added this settings up toml. And then the reverse TFT feather, ESP32S2 reverse TFT feather got updated, now has the Max 17048 battery monitor. Ditto the ESP32S3 reverse TFT. I think that also got updated from the LC709 to the Max 17048. So we had to update the guides to reflect that. And that's the
customer's hardware. All right, let's do some factory footage. And that was a little bit of a view into the factory and more. Let's do some 3D printing. All right, this week we're going to just jump right in and play these back to back. This is the Zelda project and a speed up.
You can build a prop replica of Link's Ultra Hand from The Legend of Zelda: Tears of the Kingdom. We were inspired by Link's new ability to make a 3D printed prop that uses LED noodles. It's a two-piece wearable that fits over your arm and the palm of your hand. The LEDs wrap around the armband to resemble the ability's effect like in the game. LED noodles are a flexible strand of tiny LEDs that can be powered by a 3-volt coin cell battery. We made two different sizes to fit both human-sized Hylians and smaller players alike. The armband has 3 LED noodles powered by a 9-volt battery, while the palm uses a single LED noodle powered by a coin cell battery. The LED noodles are pretty bright compared to EL wire, and it's even viewable during the day. Get the parts to build your own Ultra Hand from the Adafruit shop. We 3D printed the parts in copper PLA filament that looks great without having to do any post-processing. You can modify the open source design in CAD for a precise fit. Just update the sketches to have the parametric model update so you can make an exact fitting prop. Start by soldering together the LED noodles in series with the cathode connecting to the anode. Be sure to check out the guide on the Adafruit Learning System for a full step-by-step tutorial. This current limiting resistor is soldered to the ground wire of a JST connector for a plug-and-play assembly. The LED noodles are press-fitted into the built-in channels on the outside of the armband. This joint was soldered at a right angle to accommodate the design of the channel. The wider channels allow the noodles to bend on itself for a tight fit. Hot glue secures the JST cable to the inside of the armband to keep it concealed. A separate mounting plate is secured with screws for the 9-volt battery holder. We'll need to replace this battery's DC jack with the JST cable so we can plug it into the wired LED noodles. Then we can place the battery holder onto the mount and snap fit the cover over the holder to make it blend in with the prop. The battery holder features an on-off slide switch to power it on. The palm section only needs a single LED noodle with the ends fitting through the notch. Secure the coin cell battery mount and fit the battery holder into place with the snap fit cover placed on top. Solder the battery cables to the noodles pins with an inline resistor. Remember to add heat shrink tubing to insulate those connections. Elastic straps or rubber bands can be used to keep the prop secured to your arm and your palm. Now you can use the slide switch to power it on. We had a lot of fun putting this one together and hope it inspires you to check out LED noodles for your next light up prop.
And before we get over to INMPI, don't forget the code is PMFeather. It'll all make sense soon, but if you want to put stuff in your cart, start loading up, that is it. It'll expire tonight around midnight. Let's do some INMPI. INMPI brought to you by DigiKey and Adafruit. Thank you, DigiKey. This week it is from Texas Instruments. LadyAda, what is the new product of the week this week?
Okay, this week's new product will get you on track. It is the BQ27427. Oh, that's a mouthful. It's a new impedance track battery charge monitor for lithium-ion, lithium polymer batteries. This one is kind of nice. It's system side, so you can use it with any battery. It does not go into the battery pack. It goes into the thing that the battery plugs into, which makes it perfect for products where you have these batteries that just plug in directly and you want to monitor their charge state. Another nice thing about it, it has an integrated sense resistor. We'll chat about that. And it has the impedance track algorithm going on inside, which does a really good job, a better job of keeping track of the battery charge state, percentage, whether it needs to be charged, how many, how old it is, how many times it has been charged back and forth, because that does affect how much current you can draw from it. And it's I2C, so it's really easy to integrate. And there's a separate data sheet with all the registers information. And you can also tweak the algorithm by classifying the battery using the TI BQ Studio. So let's get right into it. Lithium polymer battery. The lithium polymer battery is very common for people designing portable battery powered rechargeable products. You know it, you love it. Some cool things about it: they're very high density, they're easy to get in almost any size, they're very inexpensive. They have a nice high nominal voltage, 3.7 volts, which means you can often use a linear or buck converter to power your 3.3 volt electronics off of it. Put some protection circuitry in it, and it's a pretty safe choice. One thing that's a little annoying about them, though, is it can be hard to know what the battery life is. And a lot of, times when you're using a product, um, you need to know what percentage of the battery life is. Is it like 2%, 10%, 25, 30, 90, 100? Because that's going to tell you how long you can use it before you need to recharge. And that can also change your use case. Like when my phone says there's 10% less, I'm going to, dim the backlight, turn off the audio, stop streaming YouTube, because I want to keep the device going as long as possible. So that information is very useful. Um, the thing about lithium ion batteries is if you go back one, so it's printed on it, the nominal voltage 3.7 volts and the nominal storage 1200 milliamp hours. But that nominal voltage 3.7 volts is just kind of like a rough number. Depending on, like in this case, your discharge rate, this is from a TI white paper, which is going to be linked in the text. How much current you draw from it is going to affect what the voltage is, because there's this built-in impedance inside the battery. So the higher the current, there's going to be a little bit of a voltage droop. So if you draw as low as a couple hundred milliamps, you're going to start at about 4.1, 4.2 volts. And then you're going to sit kind of in that 3.7, 3.8 to 3.6 volt range for like 90% of the battery life. And then it gets near to the end, and then it kind of plummets very quickly down to about 3.0 volts. But if you're drawing 3 amps or 1.5 amps, you'll see that there's this depression to the voltage, which makes a purely voltage based monitor hard to use, because if you don't know how much current is going through, you don't know which curve you're on. And so, if you're reading 3.5 volts, that could mean that if you're drawing a couple amps, you're still at 90%. But if you're drawing only 300 milliamps, it means you're at 10%. So knowing how much current you're drawing is going to affect which curve you're going to follow to determine the current battery life. Likewise, another thing people know about lithium ion and lithium polymer batteries is that they are affected by temperature. Especially in cold weather, the voltage is going to droop as well. At normal, 20 degrees C, you'll see kind of the standard 4.0 to 3.0 voltage over the life cycle of the battery. But if you are at negative 10 C, because you're in Fargo, then you're going to start at 3.4 volts before drooping down to 3 volts very quickly. So what curve you're on, current, draw, ambient temperature range is going to affect it. Another reason why just measuring the open voltage of the battery, or the loaded voltage of the battery, is not going to necessarily tell you where you are in battery life. So also, thirdly, aging. As batteries get older, the voltage drops or the impedance goes up. That can affect, based on the current draw, how much voltage droop you're going to see there as well. So, these three things are important to track: how many times you've charged it, what rate you're charging at or discharging at, and the ambient temperature. And that's where impedance track comes in. So impedance track is the trademarked algorithm from TI that uses the current Coulomb counting, which is basically counting the current going in and going out, as well as calculating the impedance, looking at the voltage, to figure out what is the state of the battery, what percentage of capacity, as well as how long it's going to take to charge up, whether it's charging or it's discharging. Everything you need to know about your battery, so that you don't have to do the work, especially if you're using a device with not a lot of microcontroller cycles to spare. You can outsource that all to this very low quiescent current chip. It'll keep track of all this for you, and you don't have to try to measure the current going through a sense resistor to determine how much current is leaving or entering your battery. There's a lot of details about impedance track. I'm not going to read this, but you can pause the video and look at it. But this is an algorithm that happens inside. You do want to have some details about the battery pack. Like, you'll need to know, of course, what is the nominal peak voltage? Is it a 4.2, 4.1, 4.3 volt battery? That depends on the chemistry, what the battery pack size is, and also it depends on the manufacturer, the quality of the battery. You might have lower or higher impedance. Also, the protection circuitry is going to affect that as well. All this you can program into the impedance track calculator by writing some couple registers, and you'll get more accurate results. the benefits we chatted about, basically does it all for you with the trade-off of that you have a sense resistor. And normally the sense resistor is external. You'd have, another component to add as well as, any pull-ups or pull-downs, capacitors or so. And what's really nice is how simple this chip is to use. So it's, I didn't put the footprint here, but it is a 9-pin BGA. I think it's like 1.6 by 1.6 millimeters. It's quite small, but even though it's a BGA, the center pad is shared with an outer pad. They're both ground, which is kind of nice. It means that you don't have to use a plugged via or like weird routing to try to get that center pad out. So you can kind of think of it as an 8-pin BGA, not a 9-pin. Just short the center pin out to the ground. You've got I2C SAL SDA, so you use that to communicate with your microcontroller. There is the integrated sensor resistor you see on the right, and then the output VSys. That is, you plug in the battery to BAT, VDD and VSS you see in the bottom there. That's just the internal LDO, so you have to put a capacitor there. You have the battery voltage coming in, goes to the sensor resistor, and then out to VSys. So this goes in between the battery and your system voltage because it has that integrated sensor resistor on the high side. The Coulomb counter is used to calculate the impedance track algorithm. And then there's two more I/O. There's the GP out. There's a general purpose output. You can use that as like an interrupt. It tells you when the battery voltage is low. It passes a threshold that you've programmed in. And there's also B in, which can be used as a thermistor input, or it can be used if you have an external thermistor inside the battery pack for internal battery pack monitoring. There's also the possibility of using it as a switch input, so you know when the battery has been cycled. That way you can reset the algorithm, because otherwise the Coulomb counter is going to go out of sync. If somebody's replaced the battery on your device, you want to kind of start over and say, okay, we have a new fresh battery. We don't know how many times it's been cycled. We don't know what charge state it's at. So it kind of resets the internal algorithm. As you mentioned, you will have to, when you boot up this chip, you want to tell it what it's connected to the best of your ability. So there's a couple things like the chemistry ID and the battery pack size, and you program that over I2C, but and they give you a list of the commands. There's also the ability to create a golden image, which is if you have a battery from your lot of batteries, especially if it's not being removed and replaced with some off the shelf battery. If it's like something well-known battery, you can do a learning cycle where you have a dead board from TI, you plug your battery in, and it kind of does this charge, discharge, relax cycle, and it calculates some of the details about the battery and how it responds to charging and discharging that you can then enter into your I2C programming. And this is Gauge Studio. So, you use their eval kit, you plug in the battery and it runs it for you. If you're doing a large run of a product and you want to get like really good, accurate, precise battery statistics data, I recommend it. If not, you can probably get away with just putting in the voltage and the current. This is an example of how you use the I2C commands to program in the chip. Note that it does not have EEPROM. It's a low-cost chip here, so it's all in RAM. So when you turn on their microcontroller, you're going to have to program it every time. So yeah, that's a trade-off of this very low-cost chip. It's like 70 cents in quantity. You do have to program it each time, but it's not a big deal. You have like this key you have to insert, and you put in the capacity and the voltage and all that. Do it every time, and you're good to go. It's not in stock, but it will be in stock soon. It was in stock when I first picked this, but it looks like it's going to be in stock in a couple months. They sold out pretty quickly. It's a nice little chip. I mean, it's very small. It's has the integrated sensor resistor, so it's like one less thing you need. You only need 2 passes. Connected over I2C, and for under like 70 cents, you can have a really high quality battery monitor for your product. Probably runs off of a battery. You want to know exactly what the state of charge is.
And that is this week's Eye on MPI.
Eye on MPI.
Okie dokie, we're going to jump right into new products.
New New.
All right, let's kick it off.
Okay, got a couple of revisions. This is a revision for the ESP32 S2 Feather. All these boards there's like a bunch of revisions because the battery monitor, speaking of battery monitors, the battery monitor chip that I originally used when I designed these feathers, the LC709203, very, very cool battery monitor, it got discontinued. And so we had to replace it. So these all got respun to use the Max 17048. And also we did the silk screen and I was added. I think it's much more legible using Penguin. It's otherwise the same. So we're going to update the tutorial for the Max 17048. But I love this new battery monitor. It's basically just as good. Maybe I'll update to the BQ battery monitor because we just covered that. But it's been revised so you can get the new version and you can see on the back it says Max 17048 battery monitor. That's how you know which version you have, other than the fact that the silk screen is fancified.
Next up.
We've also updated the 1.2-inch 7-segment LED backpack featuring the HT16K33. Is an I2C to LED matrix driver. We have these in a variety of configuration sizes. This is like a massive, chunky 1.2-inch high digits. You do have to, this is just the backpack, it's not the LED display itself, which, you know, if you see in the next image what the outline of it would be. What's updated is that, so it was kind of, we talked about how we did 300 revisions. So one of the things I did is, first up, it now has step QT ports, so it's plug and play, much easier to use. You don't have to solder in that header if you don't want to. It can make wiring much easier. Second, I've added a little boost converter. So one of the things about the 1.2-inch LED segments is that the LEDs, there's 2 LEDs in series in each segment of the digit. And so you really need 5 volts for it to look good because it's 2 volts plus 2 volts. If you run it at 3.3 volts, it's very dim. You really want 5. And so historically I said, well, you can run it at 3 volt logic, but you'll also want 5 volt power. Well, I've updated it now so you can run it at 5 volt or 3 volt, any mix and match you want, because built in is now a 5 volt little boost converter that will give you, 100 milliamps, which is all you need to drive the segments at 5 volts cleanly, even if you're powering it from 3 volts. So great for use with Steva QT because oftentimes you're plugging into a 3 volt microcontroller like an RP2040 or a SAMD21 or, a Raspberry Pi or whatever, and it has 3 volt power and 3 volt logic. So a very big update, two big updates, but this one, I think this will make it a lot easier to use.
Next up.
Okay, next up, we've got a PAM 8302 breakout. We've had a breakout board version of this, like breadboard friendly version for a long time, but I wanted one that's plug and play, that is pre-soldered, ready to go. You don't have to do any soldering to get it working. You have terminal block on one end for the speaker. You have the JST for audio input on the other. And it's just a kind of nice, 3-watt Class D amp, low cost, simple. By default, it gives you about 14 dB of gain, but into a 4 ohm or 8 ohm load. But if you look at the next photo, there is a little volume control knob. It's a potentiometer that you can twist to reduce the input from, it can be up to 3 volts peak to peak input. You can reduce it down to reduce the gain so you don't blow out your setup. So I have a little demo.
We have a demo.
I have a demo showing the kind of configuration because there's, we have a lot of amplifiers, and I'll explain why you'd want one or the other. So, oh man, I just.
Oh no!
Sorry. I was about to hit autofocus and I hit power instead.
We're back.
Okay. How did we survive? Hold on. It takes a second.
It does, but then it's all ready.
Okay, fine.
You can zoom in if you want to.
I have a lot of stuff going on.
This overhead can boot up faster if you accidentally turn it off.
If you turn it off. Why would anyone do that?
Yeah.
I don't know. Okay.
For fun.
So what's nice here is that, again, it's solder free. This is a prototype. It's green. The final version is blue or black. But green, I don't know. Sometimes I'm feeling green. Inside there's a JST 2mm pH input and you can use, we have cables that are like $1 a piece. Black is ground, red is power, 3 or 5 volts will work, and then white is signal in. And the signal is capacitively coupled here, so it can be DC reference. It doesn't matter. We'll AC couple it on the input, and then the potentiometer is the gain. Um, and then there's the amplifier. There's a couple capacitors, and then output. You can is a bridge tide load to. In this case, it's a 4 ohm speaker, and up to 3 watts. So it's fairly loud. And I don't want to get us into YouTube trouble, so I'm just going to quickly turn it up.
Stop it.
Okay.
Wait.
Wait.
YouTube police.
YouTube police.
Everyone's a cop now too. Everyone's just
It's
like
it's Cop
they're,
City.
they're just like, I'm gonna turn you in because you're doing something.
Yeah, I know. But this is great. Like, for example, this is Circuit Python and it has 3 volt peak to peak output. But, I also tried this with line level output from my computer and it works great, because you have enough gain. And then you can use use any flathead screwdriver to adjust the gain, and don't play copyright music ever. Works with pretty much anything. It's just straight analog audio in to Class D amplifier out. Very simple, but really great when you just have microcontroller audio PWM or pure DAC output and you want to amplify to a speaker.
Okay. Next up, the star of the show besides you, Lady Ada, our community, our team, entire staff and data for the community that keeps things going in all sorts of ways.
Not the cops.
That's there's nice cops too, but I'm just saying, everyone needs to stop turning each other in, and let's all get together and make and share stuff. Anyways, star of the show tonight, the product is
It's the Prop Maker Feather. So I'll show this demo on the over.
okay.
So we'll just go straight into it. So the Prop Maker Feather is the latest in our RP2040 all-in-one feather line. This is because we had a lot of people who were making projects with our Prop Maker Feather wing and the Feather M4. And the Feather M4 has been really hard to keep in stock because the 7051 is still affected by the chip shortage somehow. And people also had to solder it together, and there's 2 pieces, and they wanted better quality audio. And so I was like, maybe I'll just make it all-in-one feather. Actually, that's giving myself too credit. Dan Halbert said, why don't you make it all-in-one feather? And I was like, that's a good idea. So I did so. So what this has, I'll go to the next image, is on the left-hand side, you've got your USB-C and your battery input and your RP2040 chip. So it's a dual-core 130 megahertz processor. So you can do sensing, play back audio, do CircuitPython or MicroPython or Arduino with it. There's a reset button. There's a bootloader button. You can also use as a user button. After it's booted, you can use it as an input. There's a STEMMA QT port, 8 megabytes of flash, so lots of space for storing audio files or sound fonts, whatever you want to call them, or animation instructions. There's an accelerometer kind of in the top right corner. It's a LIST 3DH 3-axis accelerometer with tap detection, so really good for motion sensing. On the bottom right, there is an I2S Max 98357 3-watt digital amplifier. So this takes digital signal I2S from the RP2040, so it gives you really high quality audio output, up to 3 watts. So it's good for powering fairly large speakers, for props and robotics, animatronics. There's also a little servo port. We had a little space left over, and I was like, well, what are we going to use it for? And I think Phil B was the one who was like, can you stick a servo connection there? I don't know. Somebody said so, and I was like, yeah, it's a good idea. So I did. So you can plug and play a servo inside, and then there's terminal blocks for the outputs. So the NeoPixels for a button input, and for the speaker output, you've got these terminal blocks, so you can really quickly wire up a project. And there's probably a lot of projects you can do with minimal soldering, and you don't have to solder to the feather itself. You just use a terminal block. So let's go to
and
the overhead.
One thing I'll say is, a while ago, I think it was a decade ago, I'm just like, it'd be really cool if one day Disney did like Imagineer in a box to have the next generation of people who are doing like all the cool animatronics and more. And like Disney's so gigantic now, it's like it'd probably be impossible to find anyone who could help make that happen. So I'm just gonna call it that. It's like this is one of the things that you can do. Audio. You could do robotics. You could do lots of things in a really compact package, and make your own. This could put you on that path of making like pretty intense.
Yeah, I think with the Prop Maker Feather Wing, we learned a lot. Like, it was a good thing, but I think I learned a lot. Like, people really want I2S digital output. Sounds really good. and they want terminal blocks. They can plug and unplug stuff in a servo port. So I didn't have the servo plugged in before, so it was making a little bit of noise. So let's try this again. And this is Signal.
You can run scripting languages on them.
Yeah.
Yeah, it's like pretty intense. Things it can do.
Yeah, it can also run off of a battery, which is kind of nice. So I'm gonna unplug.
How much flash is on it?
This has 8 megabytes of flash.
8
So
megabytes.
lots of space for audio and more. So it runs off a battery here. This is the button input. So one of the terminal pins is just like a GPIO. So in this case, when I press it, the NeoPixels go. It's also playing audio, but you don't have to believe me. And then this is the servo output. So, it's just slowly moving the servo back and forth. But that's handy if you want to do projects where there's a little bit of motion involved. Maybe you want to, move a little eyeball or move a head back and forth, or have something spinning. You can have there's continuous rotation servos as well. And the NeoPixel output has a 5-volt level shifter, so you get nice clean NeoPixel output. And then the power to the NeoPixels and this servo and the audio amplifier can be turned on off instantaneously. So there's a transistor that can turn off those external power outputs. And the reason you might want to do that is for quiescent power usage. Like the RP2040 is a very low power chip, but still, NeoPixels do draw current even if they're not lit. And so this would let you just completely kill all that power and mute the amplifier for sure. And then, this boot button here, when I press it, it turns this LED white. And then, of course, you can add more sensors and capability over the STEMMA QT port. Just plug in vertically into it. This one has a broken connector because it's mine, but imagine it didn't have a crack in it. Plug in, a gyroscope. You can plug in OLEDs. You can plug in more servo drivers. You can plug in, an NFC RFID reader, whatever you want into the I2C. And of course, you have all the header pins as well. So you have like 21 GPIO on top of that for any kind of analog reading or digital control. Connect it to a TFT, what have you. It's like a regular feather. But I think a lot of it's built in. I kind of like that you may not more circuitry or soldering to get most projects off the ground.
Yeah. All right. And that is new products of the week this week.
New.
Okay, so we have some questions lined up already.
Yeah.
So do go to Discord, and if you haven't already, put your questions up there. Adafruit.it Discord. If you put some up there before, we'll get to them in just a minute. We're going to do some top secret, which is a little bit of a twofer. So let's kick it off. Okay, so top secret this week is part of our My Little Hacker series. And I like the intro that I made for this, so I'm going to do it again. And then we're going to talk about the latest in some toy hacking.
My little hacker, building with you is magical. My little hacker, it's time to build and show.
Okay, so we posted this up on the socials. I'm like, hey, try to guess what this is. So what is this, LadyAda?
This is, and this is the 3D rendering. I like these renderings because they really give me a good sense of what it is. And this is the CAD output. I finished writing this morning.
Yeah.
This is schematic. So this is replacement brains for the Baby Einstein tick.
Oh, you've got a whole stuff here.
No, I can.
Yeah. This is the Baby Einstein tick along, and this is a replacement board. You can pop out the board that's in there, and then you can put your own music in it. And if you know what this thing is and know how it repeats the same songs forever, you probably want to put different music in it. All right, do you want to?
Yeah, it's like this weird chip tuning. Yeah, let's go to the overhead. So this is the toy, which is now off. This is kind of like, it's a little like, you need a toy to entertain a young kiddo or maybe an adult. Anyone can use it. It's inexpensive. It's like less than $10. And it's got this button that you can press. And then there's like this little LED. It's like a screen. It's like a weird, like, it's like an AI version of an iPod. You know what I mean? It's like kind of like weird and like mutant. And it plays kind of random songs from the memory. And they're kind of, the speaker's pretty good, but the tunes are just kind of like your generic classical tunes that have no copyright infringement issues and like make your baby smart, whatever. But we want to have it play Nine Inch Nails or maybe a podcast. We don't know. Whatever you want. So we did a previous video where we opened it up and we saw what's in it. It's, of course, this blob chip. There's like 3 LEDs. I mean, look, they have to make it cheap. I don't blame them. It's a single-sided paper phenolic board. Here's the switch. And then, we did some hacking experiment. We're like, oh, can we boost this to run a ESP32S2, and we tried our I2S BFF to make music and like plug in the speaker. So we know, we basically got a proof of concept of what we wanted to do to replace the brains, because we thought like, let's make a new circuit board that fits in here. And instead of playing these pre-programmed tunes, you would be able to customize what audio you want to play. So
Yeah.
we can go back to the
This is what it is.
yeah. So it's got a micro SD. It's kind of visible at the top left, and the main processor chip is the ESP32S2. I thought it'd be cool to have Wi-Fi, because then once you've enclosed it in a case, you could use Wi-Fi. We have a Wi-Fi workflow in CircuitPython, and there's also over-the-air programming, of course, in Arduino. And then you could, once you have it set up to look for your Wi-Fi, you could reprogram it, and then also upload new files to the SD card. So you could have like new songs. You could change it out. So your kid gets really tired of the Pixies,
Yeah.
for example, you could change it to Depeche Mode. And then if they get tired of Depeche Mode, I don't know. I guess they can go to The Cure. And if
Yeah,
they get tired of The Cure, Susie and the Banshees. I mean, like,
Yeah.
there's infinite 80s goth music that you can have your kid play. So you can put any size SD card, and the ESP32S2 can definitely play WAV files in CircuitPython over I2S. There's an I2S amplifier, our favorite, that Max 98357, which we adore so much. We put it in so many things. There's a STEM QT port, so you can attach sensors or devices. Maybe you have it read data or send data, or have an OLED, or whatever you want. USB-C for uploading code, or direct communication if you don't want to do this wireless thing. A little boost converter that's kind of on the bottom center there. That takes the 3-volt battery, because we want to reuse the enclosure, so we'll take the 3-volt battery pack and boost that up to 3.3 volts, because if you're using rechargeable batteries, it's like 2.6. And we tested it. The ESP32 does not want to run, S2 does not like running off of 2 rechargeable AA batteries. You really want to have a booster to give it a nice clean 3.3 volts. And then we kind of sprinkled a couple NeoPixels, like 5 NeoPixels around, to have kind of the same background animation, but it'll be full color, not just 3 LEDs, a single color, because we like color. And then the outline is the same. We kind of moved it out a little bit, but the same pads for the battery and for the switch connector, and then the elastomer. So it should be a drop-in replacement. And then of course, it's you can't expect them to make a product like this. Would be more expensive than most people want to pay. But for people who want to hack their toys, this could be like $20 or something, and then you can
this is a nice
gutify the toy.
So kiddo has one of these, and then eventually get tired of the music. You can replace the circuit board in it, wirelessly put any music you want in there. Basically, make your own kiddo Spotify player, or like whatever. It's like it's the music that you want, and then you can over time put different music on there. And I think that'll be kind of a neat, parent kid thing. And it's sealed up. It's an enclosure that's like battle tested. These are super cheap. There's like millions of these out there. They're never going to change the design either. And so I thought this would be a good project enclosure.
Yeah, it doesn't change the behavior. Like maybe a double click does something, or like a hold. Like you can change the behavior a lot easier.
Yeah.
I did make the switch do the gain on the amplifier, because there's a gain pin on the Mac. So when you put the switch onto low power, it like drops the gain by like 9 dB. So
Yeah.
that's still functional. But one of the things I wanted to try to do is one thing I do kind of like about kids' toys is you don't have to turn them off. The quiescent current is really, really low. I mean, you use rechargeable batteries anyways, but it would be really neat if it's like, if you forget, you're like, I have so much stuff to do, you're not going to remember to turn it off. And so the ESP32, another reason I liked using the S2 is it has very, very low quiescent current when it's in deep sleep mode. And so I have to, I'm going to experiment, but I'm pretty sure that I can make it so when there's no, after it's done playing a song, it goes into this deep sleep mode. And then when you press the button, it'll wake up. In between, it should use like 30 or 40 microamperes. So it'll be able to, not as little as whatever this 8051 clone core is, but enough that it should be able to run for a couple of weeks on a low battery. I don't know. It could be kind of interesting. I mean, you could also like use text to speech, like when you press the button, it could say, what the weather is going to be, or it could have like personalized messages. I don't know. Like, I like the idea of like reusing these like really durable enclosures, and then we have, they're I don't, they're not like waterproof, but they're weatherproof. And then using the Wi-Fi workflow to reprogram them, and then they just use AA batteries.
Yeah. So this will be kind of a fun, mod-a-toy type thing.
Yeah.
That you'll be able to do a lot, and give these as gifts to people. And here you go. There's some fun songs. Emojin Heap has a neat song that they engineered to help put babies to sleep. You could just have a single serving thing where it's like, here you go.
Yeah,
This
we
plays
could
a
have
really
it,
nice song.
Drift, the
Yeah,
the
there's
Drift
another
song.
one.
They could play it
Yeah.
on loop, and then another thing is that you can change the timeouts. So I don't know. I think it would be kind of fun. Like we've done quite a bit of toy hacking, and it's interesting. It's like toy hacking and circuit bending is kind of like an old style. Like I remember in like the the early make years, that was like a really big thing. People would do toy hacking. They'd open toys and like change resistors and values to try.
This will retain someone asked, this will retain the baby proofness of it because
Yeah.
you're just opening up, changing out the circuit board and then sealing it up again.
That's why the
It's-
Wi-Fi is so cool, is that
Yeah.
as an adult, you can go in and you can change the code over the Circuit Python
Yeah.
Wi-Fi workflow. But like the kiddo can still chew on it.
Yeah, it's kind of neat that baby toys are all screws. They and it's like, it's funny, it's actually repairable, even though that's probably one of the last things people repair a lot. Anyways, so then we have a little bit of an update. I'll just play the videos, 38 seconds. This is the Teddy Ruxpin modification that we're doing. Short version, there's these Bluetooth animatronic bears on eBay for $20 or less. It's a rebooted Teddy Ruxpin. Company went out of business, so they're just sitting around. You can't put anything on them custom until now. So this is our progress with that project.
Not this Wednesday, but the 10 days ago Wednesday is when I got the audio working in the morning, and I'll see which version this is. So now let's see, get this.
Icky, sicky, 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 bubble gum, bubble gum, bubble gum. Icky, sicky, 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 bubble gum makes your hands stick to your head.
So now I've got it playing custom audio. So that's a song, Icky Sticky Bubblegum, that our Ada Kiddo likes to listen to.
Yeah, so that last picture, I went over to Midjourney and I typed in Teddy Ruxpin, Miss Rachel, and I was playing around with a couple different images. I'm like, oh, that's pretty neat. That's actually what I'm going to do. I'm going to dress up the Teddy Ruxpin as Miss Rachel. If you're familiar with Miss Rachel, she's a music teacher that does like singing videos for kids. And so I made the the graphic, and of course, I had to then later on deal with dudes on social media that said, why do you have to change the gender of the bear? Because that's what you do now. You wait around until there's a picture of a teddy bear that's in overalls, and you care about if it's a boy teddy bear or a girl teddy bear, because that's what people do on the internet now. That's where we're at. So anyways, that's what that image is. I thought it was cute.
I think this is cute.
Yeah. So anyways, that's this week's Milo Hacker.
My little hacker, building with you is magical. My little hacker, it's time to build and show.
Okay, we have a lot of questions lined up. We're gonna do this right
Okay.
away. Ready, Dana?
Bam, bam.
Okay,
Shake it up.
Yeah, I'm gonna put them on the screen so you can see them here.
Yes.
Let me question for the sure. First one, LadyAda. Hi there. I got a project I'm working on. I need to use six same I2C devices. I need them all to communicate to each other. Would this be possible using the I2C protocol?
If they're all I2C controllers, then I don't think so, because the controllers can only have one address. However, for the peripherals, you can use an I2C multiplexer. And we have 8-channel multiplexer, so like you're well within reason. So if it's like, oh, I want to connect to 8 AHT20 humidity sensors, just use a multiplexer, and we've got tutorials on how to do that.
Okay. Next one. Can you use BLE and Wi-Fi together for the PicoW?
It's a good question. I think in the SDK you might be able to, but in MicroPython, I think it might be a challenge, because I know that it's the firmware. I don't know if there's a new firmware that covers both for the Infineon Psi 43439 chip, or whether it's two different firmwares. If it's two different firmwares, then you can only run one at a time. But if there's one firmware that puts it in both modes, you can switch between the two. Then you should be able to do both at the same time. But like, boy, I don't know. I haven't tried it. I mean, this just got released like 6 hours ago.
What is CPM?
CPM is like a very early operating system, which I've never actually used, to be honest, but it was text based. It was kind of the Commodore 64 era, maybe it was beforehand. I have a feeling that Jepler used it maybe as a kid.
Yeah.
And so as a real fan, I'm wanting to get back to it, but it was a text only disk operating system.
Next up, the new Adafruit 7-segment backpack is the quick power still source voltage on the other quick port if you need to connect another device.
Yes, that it's 3 volts, it goes through, and then internally on the board, it does a 5-volt boost.
Okay, why does CircuitPython, Pico DVI display library require the use of 24-bit palette entries, but the entry only shows either black or white, no matter what values the palette's entries have?
I know that there is color support, but there might be a bug, in which case you can open up an issue. I mean, it's been a while since I tried the Pico DVI display IO library. I'm pretty sure it can do color, but it's going to map the color. But what we tend to do in CircuitPython is we don't have special, like we don't know what the display is. We let you use any color, and then we'll render it to the best of our ability. And so if you picked a monochrome display setup, you can, anything that's like darker than 50% gray will show up as black. Anything lighter than 50% gray will show up as white. And it does hue calculations to determine, like, red, is that considered black or white? In general, if you know what display you're going to use, but the display can change. So we let you set any color, and then the display driver interprets that to the best of the display's ability.
Okay. Well, this is a good one because I already have something ready for this. What will you do when Autodesk drops EagleCAD in 2026? We have an entire video segment last week on Ask an Engineer.
You can watch it.
You can find it, just scrub to it, and we talked about that. But I'll also tell you, it's not really a rant, but I'll also say typical Adafruit style, as we show us migrating away from EagleCAD, like some of us use KiCad on staff. But as we show it, we're going to show, here's some tips. Here's some things we do. We already donate to KiCad. We already support it in all the ways that you can. We think we could do some bounties to help add some new features. But just like everything else, we'll show our work as we go along. And I think you'll like it because every single week we'll have something like, oh, here's a new thing that we learned in KiCad. Here's another thing. Here's another thing. We converted from EagleCAD. Here's some other stuff. So anyways, it'll be fun. Yes. But check out the video segment.
I'll say I haven't looked into it in depth. I don't know what we're going to do yet. But I'm up to either, I want to try both KiCad or Fusion 360, and I'll make the right decision for me.
Okay. Next up, Jeff Curling interviewed Abhinav recently, who was not exactly positive about RISC-V for the moment. He seemed to think that it'll be something close to a decade, as I recall, before RISC-V ecosystem has matured up. Compete with ARM, for him to consider Raspberry Pi. This seems pessimistic to me. What do you think? Here's what I think. Evan is really smart, and if RISC-V makes sense for Raspberry Pi products, you'll see it.
He's very cost optimized.
Yeah,
so
he's not gonna.
Really,
yeah,
he will go with whatever the cheapest thing is if it has the equivalent behavior and performance, but he doesn't want to maintain the performance.
Yeah, my experience is they usually make really smart decisions, and so we get asked like, when are you going to switch to RISC-V? It's like, well, when all of the reasons that we would need to make sense. There's been a couple microcontrollers with like some RISC-V chips, but not supported.
Yeah, the main
for the most part yet.
Main core RISC-V chips have not done particularly well. ESP32C3 is RISC-V. It's one of the few that I think is successful and actually made it to market and have like real use cases and users. It's very early, and it takes a long time to get the maturity, but it's definitely, it's becoming more used. I was asked a couple of years ago about RISC-V where I thought, and I think it's a great replacement for 8-bit cores and 8051 microcontroller cores. Like, you can use RISC-V instead. You get the power of like a 32-bit RISC architecture without the cost of licensing ARM. But I don't know. I mean, Evan knows more about chip design than I do.
I mean, one thing for us, if there was like a low-cost RISC-V microcontroller that had USB,
I'm gonna check it out. Yeah. We port CircuitPython to it probably.
Yeah, those are things like we have a core set of things that we like to see in microcontrollers if we're gonna port CircuitPython to it, but that would be nice. Is there any update on the Nightjar analog electronic bird synthesizer? Get into it. It's just on the long list of things that
I did get the toy hacker thing done, and that's been 4 months old.
So
it's happening.
Some things have just moved in slow motion between kind of recovering from COVID and part shortage. Like all these things together, just kind of perfect storm.
And 300 redesigns.
300 redesigns.
Baby.
But yeah, but you'll notice like momentum is happening. So we'll get there. We also have Ada Box coming up. It's happening. It's just like sometimes it feels like you're running through molasses. But the thing is, if you're running through molasses, keep on running. Don't stop. Question for the show with the baby hacking SP32S2 board. Thoughts on adding an inexpensive proximity sensor to reduce the volume if the baby takes it up to their face? Maybe even helpful if the LEDs dim. That's a good idea.
That's something you could like easily add with the STEM QT ports. It's a perfect example. We have a lot of low cost proximity sensors. You could tell, if it's being held. Well, the speaker's on the back, but you could, drill a hole and have the sensor point through, and then you could tell if if you're a kid who likes to put it up to their ear because they want to blast their eardrums. Yeah, put on the Led Zeppelin or something, or Jack White, make it loud, and they could, you could reduce the volume that way digitally. Again, I2S amplifiers make it easy.
You can also pre-record your own messages from like grandparents, and the kids can listen to it. There's a lot of things you can do with that.
And high quality, not like, don't get me wrong, I love those, the ISM chips, but man, nothing beats 44 kilohertz wave files for good quality audio.
What are the blue resistors with the extra stripes? When would they be used over 5% resistors?
Sometimes you want precision. They're usually 1% or 0.1%. Sometimes like current sensing, you don't want to have variation. Sometimes they're used for an op-amp circuit where you don't want a 5% variation in the frequency generated or filtered. So you do use 1% resistors once in a while. These days, to be honest, a lot of people use surface mount, and the surface mount cost is almost the same. I tend to use 1% usually for like the feedback resistors and the boost converter, because 5% here, 5% there. You don't want your output voltage to vary by 5%. You want it to be like right on the money.
Okay. And that was all the questions of the week this week. Thank you, everybody. That's our show. Special thanks to Cara behind the scenes, doing some stuff and more, helping the show run smoothly. Very much appreciated. Don't forget the code is PM Feather, 10% off. We'll see everybody throughout the week. Thanks for the great questions and hanging out with us. We will be back next week. Yeah, you can see the green part.
The green part.
We have a green screen. Cool. This has been an Adafruit production. Here's your moment of dinner. Good night, everybody.
Good night, everybody.